Let us see how to find a count of pairs that form a complete day and build a solution in JavaScript and compute the time complexity and space complexity of the solution that we will be building. First, let us try to understand what the problem statement is. The problem says that you're given an input, let's say 12, 12, 30, 24, 24. You have to find pairs, two values, which will form a complete day. What a complete day means is 24 hours. It needs to form 24 hours or a multiple of 24 hours. So this plus this, let's say 12 plus 12 gives me 24. So this is a full day, which is a valid pair. Then you say this 24 plus this 24. 24 plus 24 gives me 48. This is a multiple of a full day, so this is also valid. Hence, we found two pairs here which were valid. So this is valid, this is valid. If I try to do this plus this, 12 plus 30 gives me 42, which is not a multiple of a complete day. It has to be a complete day. So this is not a valid use case. So that's the problem statement. And in terms of trying to find the solution, what we will be doing is we will be using a frequency tracker. That's why we call this a hashing approach, because we will be using a tracker to keep count of our frequencies of this pair, and in the end just return the result that we form from this frequency tracker. So it is more like hashing and counting frequencies approach. So what we will do is we'll be using something called as complement. First, we will say from 24 hours, based on whatever hour you have received an input, let's say 12, how much time is remaining to make a complete day. And how we will get this is, let's say you have received input as 12, so you say 24 minus 12, which gives you 12 is the number of hours that is remaining. But this input can also be greater than 12. So just to make sure everything spans across 24 hours only, what we will do is we will say 24 minus 12 mod 24. So this value that is received stays within the 24 hours bound. And then similarly, to make sure that the complement that we receive, which is going to be 12 hours, stays within the bound of 24 hours, we'll also do a mod of 24 here. So this will ensure, this mod and this mod will ensure that the value of the complement that we receive, complement basically being how many more hours do you need to make a complete day, or its multiples. So this will make sure that whatever complement value you have received is going to stay within the bounds of 24 hours, and this value we are going to keep track in our tracker frequency, and based on that just increment the result values that we have. So once you get the complement, just increment the counter if you have the complement. This will translate into code something like this. So what we will say is keep a frequency tracker. So I will say frequency is equal to new array of 24. I want to just make sure that I will reach up to 24 hours, and at the start I will mark everything as 0. Then what I will do is have my result, which is going to be my counter, because the output of this is going to be the number of pairs that you find. And I will just say return my result that we get. And then what I will do is I will go through the hours input that I have received. I will try to get my complement, which is going to be basically 24 minus the hour that you have received. And we have to make sure this hour is within the 24-hour bound, because the input can also cross 24. It can be 35, 37 hours. So we have to make sure this hours is within the bounds of 24. And after we get the complement, we will also do mod with 24 to ensure that the value that we receive is within the bounds of 0 to 23 hours. It's not crossing those bounds. Sometimes it can be -1 or something, so we don't want that. We just want it to stay within 0 to 23 within those bounds. And once you find the complement, what we are going to do is the result that I mentioned we will be keeping track of, that result has to be updated now. And that result will be something like this. So we just say result plus equals whatever frequency tracker you have and just say complement. So whatever value you have for that complement value, you just increment it. After you find the complement, we will pick this remainder value which I mentioned, that is the number of hours mod 24, number of hours that are remaining to make a full complete day. And what we will do is in this frequency tracker, for this remainder that we have, we will just increment the value something like this. So what we will say is plus plus, and this is the hours remainder, and we store it in this array and we just increment the value. So initially it was 0 and then we just increment it and keep on incrementing for this remainder value. As long as you are within the bounds of this hours array, you find the complement, you increment your result based on whatever frequency is there for that complement of yours, and then whatever remainder you have here, this is the remainder, you just increment the frequency for that remainder. And then at the end, whatever result you are left with, you just return it. And the time complexity of this solution is going to be big O of n, because we are iterating through all the hours. Because to find the pairs, you have to go through all the hours. You cannot just go midway and say I have iterated through everything. And the space complexity is going to be big O of 1, because we just use this array here with a fixed size of 24 and then just fill it. So it's not going to go beyond this 24 hours mark. That's why big O of 1 in terms of space complexity. Now you will say, why did you do something like this? Why did you use this counting approach and not a simpler approach? A simpler approach will be brute force approach, wherein what I would do is just take one element from the array and iterate through the entire array to find another element to make a sum of 24, which would be like using an outer loop and then an inner loop, which will be time complexity of big O of n square. In comparison to that, this is more efficient. That's why we didn't use the brute force approach, and we will just proceeded with the hashing approach. That's pretty much it. Thank you for watching. Please like and subscribe.